Here we go. No, don't talk to your neighbor yet. Okay, so I want you to thumbs up when you have a guess on this one. Before you have a conversation, I want you to answer the second question. The same scenario. Different question. Thumbs up when you have an answer to this question. Okay, I'm going to go back to this one. Tell your neighbor the answer to this question. And then tell your neighbor the answer to this question. Tell them why you think so. All right. What do you think of this original question? What's the correct answer? I got one vote for D. Dangerous dinosaurs is correct. Okay. So rotational speed is how quickly you are going in a circular path. Okay. Both are doing 360 degrees in the same amount of time. They're going in a complete circle in the same amount of time. They have the same rotational speed. Okay. So rotational speed can have units of rotations per second, revolutions per second, degrees per second, or radians per second. Okay. Also, have you ever heard of RPM? RPMs, rotations per minute. That is another unit of rotational speed. It's how quickly you're spinning, how quickly you're completing one revolution. Okay. Good with that? Versus speed, this is what we're used to. This is what a speedometer says. Okay. Now, if you're running track and there was not a staggered start, which lane do you want to be in, on the inside or the outside? inside. Why? Shorter, less distance. If here's the starting line, which one, and the finish line, which one wins this race? They tie. Everybody okay with that? So in order for the green one to win, to tie, but runs a greater distance, what does that mean about the speed of the green? Has to be greater. The equation-wise tells us this. We know that they had the same rotational speed, both complete 360 degrees in the same amount of time, but the green one had a greater radius. Therefore, the green one has to be going faster. Does that make sense? The comparison between rotational speed and just normal, regular speed. Good with that? So this is straight off the pre-quiz. Correct answer is yes. Acceleration is the rate at which velocity is changing. Velocity communicates two things. What are those two things? Speed and direction. If you change either one of those two, or both, you have acceleration. Okay? The acceleration that we dealt with last semester was speeding up, slowing down. Okay? If you're just changing your direction and not changing your speed, it is experiencing acceleration that we call centripetal acceleration. Okay, to give you a conceptual, so you saw the math from the pre-quiz. To give you a conceptual understanding of what centripetal acceleration is, this is not a great. This would not hold up in college, but we're just going to go with it. So if I'm going in a circular path, my direction of motion is going this way at this point, this way at this point. Like if I was being swung around on a rope and I got let go right here, I would just go in the tangent path. The direction of my velocity at this point is going this way. The next moment, my velocity is going this way. Next moment, my velocity is going this way. How quickly this velocity changes towards the center of the circular path communicates centripetal acceleration. So how quickly this is changing your velocity towards the center of the path. You okay with that? Okay. Now, if you are moving at a constant speed, you have what's called a uniform circular motion. That's what this is. And that's what you'll experience in this class for circular stuff. The cool thing is there's some parallels between what we learned in Newton's second law last semester and circular motion. So the net force is equal to mass times acceleration. The centripetal force is equal to mass times centripetal acceleration. Okay, so just like the net force causes acceleration, the centripetal force causes centripetal acceleration. And just like the direction of the force determines or is the same as the direction of acceleration, the direction of centripetal force is the same direction as centripetal acceleration. Okay. Give that one a shot. Tell your neighbor. Correct answer is C. Towards the center of the circle. Always. Okay, centripetal force is always towards the center of the circle. Centripetal acceleration will always always be towards the center of the circle. Okay. Just a hint. I put these here intentionally. Tell your neighbor. Okay, what do you say? Got one vote for B. Got a vote for C. Some votes for B. Got a vote for D. Okay. To answer this question, I would highly recommend using the equations to guide your thinking. This one's kind of fuzzy. We'll come back to it, but this one's definitive. Both balls have the same rotational speed. That's really nice. So the only thing that's going to determine it is how far away it is. Which one has a bigger radius? The green. So the green has a greater centripetal acceleration. You might have also come to that conclusion with this, but this is a little fuzzy because you got speed on top and radius on bottom. They're changing. Both of these are changing. You might have come to the right conclusion because you're like, oh, look, speed's more influential, has more weight because it's squared. That's a little fuzzy, but that one's definitive. Good with that? All right. Example problem. So, how fast can a 400-kilogram car take a non-banked circular entrance ramp that has a radius of curvature of 20 meters before it starts to skid while moving at a constant speed? The coefficient of static friction is 0.54. Coefficient of kinetic friction is 0.43 between the tires and the road. All right, here we go. First step, This is going to have some reminiscence of first semester. Free body diagram. What is playing the role of centripetal force? What force is playing the role of centripetal force? Friction. So friction is going towards the center. Okay. Is that going to be static or kinetic friction? Static. We're right before we start slipping or sliding, and specifically it's maximum static friction. Okay. Now, a more helpful free body diagram would be to draw the car as seen from the backside. So like here's the license plate. Here's friction. Gravity and normal force. Good with that? Step 2 is pick the positive direction. You are always going to make towards the center of the circle positive. So I'm going to make to the right positive X direction and up positive Y direction. Is the sum of the forces in the X direction equal to 0? Is inertia doing what it wants to do in the X direction? Is there acceleration in the X direction? Yes. There is acceleration. Inertia is not doing what it wants to do. Therefore, the sum of the forces in the X direction are not equal to 0. In the Y direction, are the sum of the forces equal to 0? Is inertia doing what it wants to do? Is there acceleration in the Y direction? Inertia is doing what it wants to do, and there is no acceleration. Therefore, the sum of the forces are equal to 0 in the Y direction. Okay. So, next up, if maximum static friction is equal to mass times acceleration, here's the slight tweak. Instead of just normal acceleration, we're going to say, because we're moving in a circular path, centripetal acceleration. And in the Y direction, we have normal force minus force of gravity is equal to 0. Good with that? Now, more often than not, you're not going to leave that like centripetal acceleration. Centripetal acceleration is equal to speed squared over the radius. It's also equal to rotational speed squared times the radius. More often than not, you're going to substitute either one of these two equations in for centripetal acceleration, depending on what's being asked of you. Unless they ask you straight away, hey, what's the centripetal acceleration? Okay. In this problem, they're asking for what? So which one of these two do you think we're going to use? The one with speed. So I'm going to substitute that in for here. So I got maximum static friction is equal to mass times speed squared over the radius. So now I've got an expression, I've got something with speed in there, okay? I've got the mass, I've got the radius, I'm looking for speed. Do I have maximum static friction? is that 0.54? What is 0.54? Coefficient. That's this thing. Remember that? So you have maximum static friction, so we need to incorporate this equation. Maximum static friction is equal to coefficient of static friction times normal force. Man, I remember doing this. Okay, so I've got 0.54, but how do I find normal force? Over here. So normal force is equal to force of gravity, which, do you remember, that's equal to mass times 9.8. Oh, yeah. So normal force is equal to 400 kilograms times 9.8. That's equal to 2,117 newtons. What do I do with that? Bring that. Oops. Pop that in here. So 2,117. Oh, no, it's not. Just kidding. That's not 2,117. Sorry. That's equal to 3,920. That's close to 10. It should be close to 4,000. Guess what's equal to 2,117? 0.54 times 3,920. There, that's 2,117. My bad. And stick that in there. $400 divided by 20. $2,117 divided by 20 is, I think it's 106. Square root of 106 is 10.3 meters per second. Which is roughly 25 miles an hour. Have you ever seen an entrance or exit ramp for 25 miles an hour? They have them in the cities usually. It's like one of those they have to merge on and off of super fast and like pretty tight radius. Good with that? That is the extent of the math that you will have to do for the worksheet. That's due on Tuesday. So you can either interpret that as no homework this weekend or give you a chance to jump on it. But you know all the stuff you need for that worksheet. Okay? Questions here? These are the steps to how to bake a circular motion question. We just went through all of them. The only thing I didn't do is if you're given or asked to find the period then you need either incorporate this equation or this equation. That's the only time you find period. But those are the steps. Apply those correctly, and there you go. Okay. Thumbs up when you have a guess. Have a conversation. Yeah, did I forget to put a slide
Yeah.
But the radius is Sweet? Sweet? I know. I get it. Because the song is the same. So it has to go slow. The same. Oh, the same time, but a bigger distance. That makes more now. I had the right idea, but that makes more sense.
Okay. Correct answer is
D or B. Not even a D.
okay. We're gonna do B for decreases.
Yeah. That's what I was going for.
Okay. So here's what I'm gonna suggest. I'm gonna coach you to think of it in terms of the math, and then use the math to influence your concept. Okay. So here we say the speed is is going to be the same. So that doesn't change. If the radius increases, what will have to happen to the rotational speed in order to keep this side the same? Has to decrease to keep this side the same. Okay. You could also do it like this. You could rearrange it like this because I'm asking for rotational speed. This stays the same. This goes up. Therefore, this goes down. It's another way to look at it. Okay. Then conceptually, you're going in a circular path at a certain speed, and then you increase the radius, but you still maintain that same speed. It's going to take you longer to complete that 360 degrees at a bigger radius if you're moving at a greater speed. Sorry, if you're moving at the same speed. Good with that? Okay, a warm-up question is, what force is playing the role of centripetal force in this example? Tension. So this is that. Have a conversation. Correct answer is? Correct answer is B. Decreases. Okay. So here, so the mass isn't changing, the speed's not changing. The radius increases. Therefore, the force, the centripetal force, inversely proportionate. You say inversely or indirectly in math-wise? Inversely? Is that what you get? Okay. Inversely proportionate. Good with that? Thumbs up when you have an idea. Tell your neighbor. Correct answer is A. 9 times, because when you triple the speed, you must square the 3 and the v. Good with that? Thumbs up when you have a guess. Talk to your neighbor. Correct answer is A, increase. If you double the speed and double the radius, these two don't cancel each other out because you first must square it. So we end up with 4v squared over 2r, and that becomes 2 times the amount of tension. Good with that? Last question. Thumbs up if you have a guess. Correct answer is B. Decreases. No. Yes, B. Decreases. Okay. Here's progression. So mass is going the same. Radius is the same. Increase in the tension. Therefore, the speed has to increase as well. So going over here, if we increase the speed, radius is the same. Tension has to, the period has to go down. Okay. You could have that same conversation with these 2 equations. Okay. Good with that? Questions there? Yep. That's today's lesson.